Here we're back at trying to solve exponentials. Well, for these two here, excuse me, you can force a common base. So this can really be 3 to the third power. So if that's the case, then we can come up with the logical conclusion that x squared minus 1 must be equal to 3 because the exponents must equal each other. So now we have x squared equals 4 and we get x equals plus or minus 2. Over here, same thing. We can actually convert this to 4 times 4 is 16 times 4 is 64. So 4 to the third power there. So now I have x squared plus 2x equals 3. So x squared plus 2x minus 3. Get those instincts right. We want to get everything to one side, other side equals 0. X plus 3 times x minus 1 equals 0. So that's where we're getting our two answers of -3 and 1 for that problem. Okay, life's a little bit more challenging when we have a 3 and a 7 as a base because we cannot find a common base here. So in that case, we're going to do two things. First of all, we're going to take the natural log of both sides. But then we're going to take the exponents in front. So I got 3x, we got 2x minus 5 out front, and then times the natural log of 3 equals x times the natural log of 7. Okay, we're looking for the exact answers. We're going to crank this out, not try to find a rounded answer along the way. So now I'm going to distribute through. So I have 2x natural log of 3 minus 5 natural log of 3 equals the natural log, x times the natural log of 7. Okay, well I got an x here and I got an x over here, so I want them on the same side. So I could do this two different ways, but I'm just going to subtract 2x natural log of 3 here because that will get rid of it, and I will subtract 2x natural log of 3 right there. Well, now I have -5 natural log of 3 equal to, and then we're going to factor out an x. So that will leave natural log of 7 minus 2 natural log of 3 because we want the x by itself. Divide both sides by the natural log of 7 minus 2 natural log of 3 so that those cancel. And then this would be our exact answer to this problem right there. Okay, so you can go ahead and throw that on your calculator, get the decimal answer as well. Practice that, but that's the exact answer. Okay, over here, we have same concept. We have bases that we cannot force to be the same. So two steps, we bring the power out front. The only reason we can bring the power out front is by taking the natural log of both sides. So I've got 3x plus 1 times the natural log of 4 equals the natural log of 5. Distribute through 3x natural log of 4 plus just the natural log of 4 equals the natural log of 5. So I've got 3x natural log of 4 equal to the natural log of 5 minus the natural log of 4. Be very careful of making that natural log of 1. It's actually not, remember, subtraction's the same as division with a single log. So that would actually be the natural log of 5/4. But you can leave it just like that and divide both sides by 3 to get rid of the 3 and natural log of 4 to get rid of the natural log of 4. So if we do that to both sides, this would be the exact answer that we are talking about there. All right, and this one here, for number 30 here, all we got to do is literally take this and put in a value of t that they gave you. A very simple problem if they give us the time. Well, the thing is about this one, they didn't give us the time. They gave us the population after some time. So how much time does it take? So we start with the population after, which is 1,000. The initial is 300, and we have e raised to the 0.22t. Okay, well this is where all of our solving is going to be applied. We got to get the 10/3 on one side first, and then on this side we have e to the 0.22t. So what we do here is we take the natural log of 10/3 equal to, just like the last problem we were working on, 0.22t times the natural log of e. Well, the natural log of e is just 1, so I'm running out of space here. I wonder if I can write here. No, I can't. Divide by 0.22 over here, divide by 0.22, And we get time as approximately, well, let's see. The problem was second natural log of 10, whoops, what happened there? Okay, just please stand by. Control, natural log, thirds. So we're taking the natural log of 10 thirds, and we're going to divide by 0.22. Okay, we can see that's exactly what I wanted to do right here. See how that pops up? You see that? Okay, so 5.47 it looks like. So approximately 5.47, what's our unit? Minutes. I always want to get the minutes correct on that. Okay. All right. So on this one here, I'm not gonna do this one because it's literally just another practice problem exactly like that one. I suggest you try 31 and you check the answer solution key to see if you're getting it right. But it's just like this one. Okay. Moving right along then. Our next section will be 32 here. So now a compounded continuously investment is this formula right here, which we saw a lot of. So how long would it take for investment to double in value? Well, that means if I start with a 1, it's going to end up at a 2. So initial or principal amount 1, amount afterwards would be a 2. So 2 equals 1, e to the rate, make sure you do 0.052, and then times t, that's our unknown. Remember, e is not a variable here, okay? So since you could have easily chosen 10 and gotten to 20, right? 10, 20, 5, 10. However you think about it, you're going to end up getting a 2 on the left. So to get that 1 out of there so you're not confused, this literally says e to the 0.052t. And then we're going to take the natural log of both sides. So now we have the natural log of 2 equals 0.052t times the natural log of e, which is 1. But then we divide by 0.052 to both sides. So those are gone, and then we're going to crank this out. So on my calculator here, I get second natural log of 2. Why it's not accepting that 2, okay? And then we're going to take that answer and divide by 0.052, 5.2%, and we click it. And that's like 13.33 years. So approximately 13.33 years, okay? Likewise, I'm not going to do number 33 because that's just tripling, so hopefully you can try that and see if you're matching up. They told you a K value here, it looks like. We're taking it easy on you. So we got a K value for this carbon dating problem. So basically, what's the percentage of carbon we have left? You can start with, if you want, like, oh, I got 100. But it's going down to 25. That's what that means. You have 25% of its normal percent of carbon, or of its normal amount of carbon. So e raised to the k times t. Well, remember, k is known, so we can take that and we can plug that right in there. But here's the deal. When you divide both sides by 100, you're going to get 0.25. You're going to get 1/4. You're going to get 0.25. So we really could just start here with the problem for the carbon dating. So now when we take the natural log of both sides, you're essentially just taking the natural log of the percentage as a decimal, and we set that equal to k t times the natural log of e. Well, we know the natural log of e is 1, so all we got to do is divide by k. Okay, so in this case, divide by negative 0.00012 since they told us to use that value. So if I do that, and I do natural log of 0.25, and then I go to the bottom. I really hope that's a 0.25. That's really hard to see. Negative 0.00012, and I hit enter here. Now, that did not work, so I'm going to try that again. I'm sorry. It did not click the decimal. So here we go again. Natural log. I don't know why it's not clicking. 25. And then we're going to divide that by negative there's 2 of them now, 0.00012. 0, 0. Oh, that's not there. 1, 2. That should be it. Okay, there we are. So it looks like 11,500. Now be careful here. I'm going to go up and pull this down because it looks like my calculator rounded more than I would really want it to. So 11,552. If I'm going to go to 2 decimals here, 11,552.45 years. Okay, now I'm assuming this one right here is going to be a lot like it. There it is. You can try that one on your own.